Let's move on to a different type of group decision-making problem, namely the problem of fair division. So here's the setup. Suppose that there's a set G of objects. So we have some items, and these items must be divided among a group of people. Now, before we start thinking abstractly about this problem, there's a few questions we have. First of all, are the items divisible or indivisible? Can we divide the items themselves, each item in the set, can we divide that item up? Can we split it up or not? Is it an indivisible object? And there are really three options here. First, that we have a set G of just indivisible objects. We cannot split up any of the objects, and we just have to divvy them up among all of the individuals. Or perhaps we have a few divisible objects. So there's several objects, and they may be divisible. Or there's a single heterogeneous object. So there's a single object. We're assuming the individuals have different opinions about that object. The metaphor here, the metaphor that is often used is that of a cake. Imagine that you're at a birthday party and you have this cake. Part of the cake is chocolate, part of the cake is vanilla, and you have a group of individuals, and some people like chocolate better than vanilla, some people like vanilla better than chocolate, some people don't even like cake. The question is, how can you divide that one object, namely the cake, among all of the individuals at the party? So there's three. When you talk about the problem of fair division, you need to first determine what type of fair division problem are you dealing with. Do you have indivisible objects or divisible objects? A related question, are we allowing side payments? What side payments allow you to do is essentially move from a situation where you have only indivisible objects to a situation in which you have some divisible objects. So you can use the side payments, you use money as compensation for giving an object to one particular person. So in effect, what money or side payments allow you to do is move from a setting where you have just indivisible objects to a setting where you have some divisible objects. Another question, are we dividing goods or are they bads or chores? Now, of course, if all of the objects are of the same kind, either all good or all bad, then the problem of how to divide up those objects among a set of individuals is very similar. It becomes different if we allow that there are some objects that are positive, that assign positive value for some of the individuals, and some objects that assign negative value, that are assigned negative value by some of the individuals. Then that'll be a slightly different type of fair division problem. Another question, how are we representing the preferences of the individuals? So typically you assume that the individual utilities the individuals have utilities which are assigned to goods. And what's a utility? Well, a utility function for an individual I is just going to be a function from the set of goods. So for each good gets assigned some real value, positive or negative real number. And that real number is the utility you assign to that particular object. So the question is, does this utility function represent just ordinal information about the agent's opinions or preferences over the objects, or does it represent cardinal information? We've touched on this distinction before, but just to remind you, suppose that there's three objects, G1, G2, and G3, and we have this individual I. Now let's say individual I's utility for G1 is 3, for G2 is 2, and for G3 is 1. What this means is that individual I prefers G1 over G2, and G2 over G3, and G1 over G3. You just read that off because the individual I assigns a higher utility to G1 than to G2. What we have represented here is just the ordinal information about the individual I's preferences over the goods. The distinction with cardinal information is suppose that the utility for individual I is something like 10, 2, and 1. Now, these two utility functions, ui and ui prime, represent exactly the same ordinal information. They represent the exact same ordering over the objects, but they represent different cardinal information. In particular, the utility assigned to G1 is much higher than the utility assigned to G2 or G3. So whether or not this difference, the difference between these two utility functions, matters is an issue of whether or not we're assuming ordinal utility functions or cardinal utility functions. Another question. When we divide up the goods among all of the individuals, what makes one division better than another division? One way of approaching this problem is to just simply try to measure the overall social welfare. So you look at everybody's utilities and you somehow measure the social welfare. Now, this is a very big topic, and it's not a topic that we're going to spend much time on. But let me just throw out a few notions, a few concepts. There's different ways of measuring the overall social welfare. One approach is a utilitarian approach. The idea here is you just look at all of the utilities for each of the individuals and you try to maximize the overall sum of the utilities. That's a utilitarian approach. A second approach, so-called Rawlsian or egalitarian approach, is to try to maximize the worst off. You maximize the minimal utility assigned to one of the individuals, to any of the individuals. So egalitarian are going to favor divisions that are more equal, where each individual receives roughly the same amount of utility. Whereas a utilitarian may prefer divisions in which some people end up with much more utility than others. Roughly in between these two ideas is what's called Nash social welfare, named after the famous game theorist John Nash. There you want to maximize not the sum of the utilities, but the product of the utilities. And the idea here is that you get a little bit of the best of both worlds. You favor a more equal distribution, but you also want to somehow maximize the overall utilities that each of the individuals receive. Just to illustrate the distinction between utilitarian and Nash, note that for Nash, for the Nash social welfare, since 3 times 5 is less than 5 times 5, so 25 is greater than 15, Nash is going to prefer a distribution that is more egalitarian, while still trying to maximize the overall utilities for each of the individuals. Well, this is a big topic, welfare economics, issues about social welfare. It's a big topic. We're not going to spend much time talking about it, but I just wanted to highlight some of the key concepts that may play a role. Finally, are the preferences over bundles or allocations? So if we have a set of objects, we're going to need to divide up these objects among each of the individuals. And so what that means is that some individuals might receive more than one object. The question then becomes, what is the utility that the agent assigns to that bundle, that collection of goods? Now, we know we're assuming that the agents have utilities over each of the individual goods, but can we use that to somehow read off what the utilities are for a set of goods or a bundle of goods? Well, there's different assumptions you might make. One central assumption, one common assumption, is that allocations of goods are separable, meaning that the utility you attach to the overall set of goods can be divided among all of the objects that make up that set or make up that allocation. A particular way of implementing a separable utility function over allocations is to assume that it's additive. Here, the utility you assign to a set of objects is just the sum of the utilities you assign to each of the objects. Or you might just think a bit more abstractly that each agent or each individual has a preference ordering over the set of objects, and you somehow lift that to an ordering over sets or collection of objects. Well, fair division is a big topic. We're not going to be able to touch on all of the aspects of fair division and social welfare. I want to focus primarily on the algorithms and methods that you can use to fairly divide a set of objects. I also want to look at a few paradoxes or puzzles that arise. But let me just point you to 2 books where you can get some further reading, to get some further information. The first is the book by Moulin on fair division and collective welfare, and the second is a book by Stephen Brams and Alan Taylor, which covers a number of topics which we'll discuss in this course.